Tertiary halogenoalkanes undergo SN1 reactions, where S indicates a substitution reaction is occurring, N indicates that a nucleophile is involved, and 1 indicates that only one species is involved in the slowest rate-determining step. In tertiary halogenoalkanes, the small hydrogen atoms in primary halogenoalkanes are replaced by bulkier alkyl groups. Tertiary halogenoalkane. The bulky alkyl groups do not allow attacking species to approach the central carbon atom. Consider the reaction between 2-methyl-2-bromopropane and a hydroxide ion. It has a two-step enthalpy profile. The first step, the heterolytic fission of the carbon-bromine bond, has a high activation energy, EA1, and therefore determines the rate of the reaction. The first step involves only the halogenoalkane and proceeds via a transition state complex to form a carbocation. The second step has a much lower activation energy, EA2, and hence is considerably faster than the first step. The carbocation reacts with a nucleophilic hydroxide ion via a second transition state to form the product 2-methyl-propan-2-ol. Transition state, carbocation, EA2, SN1 reactions. Primary halogenoalkanes undergo SN2 reactions, where the S denotes a substitution reaction, the N shows the reaction involves a nucleophile, 2 is the number of species involved in the slowest rate-determining step. A nucleophile is an electron pair donor. It is attracted towards species carrying a full or partial positive charge, with which it can form a dative covalent bond. Consider the reaction between a hydroxide ion in solution and bromoethane. Both reactants are involved in determining the rate of the reaction in a one-step process. The hydroxide ion attacks the carbon atom from the opposite side to the halogen atom, because the bromine atom, A, is so large it impedes the approach of the smaller hydroxide ion, and B, it repels the negative charge nucleophile. The lone electron pair on the nucleophile forms a new dative covalent bond with the partially charged carbon atom to give an unstable transition state complex. The complex behaves like an umbrella blowing inside out as the bonds rearrange into a tetrahedral structure. A bromide ion, called the leaving group, is released. Transition state complex. SN2.